This problem says a bowling ball rolls up a ramp 5.5 meters high without slipping to storage. It has an initial velocity of its center mass of 3 meters per second. What is its velocity at the top of the ramp? If the ramp is 1 meter high, does it make it to the top? All right, so this time we have the bowling ball. So here's the ramp. Here is its velocity initially, and it's rolling without slipping. And at the top, we want to find it. So this is the initial velocity, there is the final velocity. Okay. Hello? Hello? All right, so in this problem, what we'll do is we'll use energy conservation principles to solve it. Okay, so at the bottom it has translational kinetic energy and rolling kinetic energy. At the top it has potential energy, translational kinetic energy, and rolling and rotational kinetic energy. So from energy conservation principle, 1/2 mv initial square plus 1/2 I omega initial square is equal to 1/2 mv final square plus 1/2 I omega final square plus mgy final. All right, and v is related to omega like so, is r times omega. So we'll substitute this and write everything in terms of v. Okay. So for all these omegas, we'll substitute from this formula. Omega is v by r. And the moment of inertia for a bowling ball, it's a sphere, and so moment of inertia we saw I is 2/5 mr squared, where m is the mass of the bowling ball. Okay, so let's substitute all of this. Okay, so this equation becomes 1/2 mvi squared plus 1/2 I is 2/5 mr squared. Omega I is vi squared by r squared. And that's equal to 1/2 mv final squared plus 1/2 I omega squared 2/5 mr squared v final square over r squared plus mgy final. Okay, you will see that, you can see that the mass cancels from every term, so that's a good thing. Irrespective of the mass, the final velocity will be the same as long as the radius is the same. The radius square cancels. All right, so what we have is, and this 2 cancels, so 1/2 vi square plus 1/5 vi square is equal to 1/2 v final square plus 1/5 v final square plus gy final. All right, 1/2 for, and 1/2 plus 1/5 is, so let's figure that out. 1/2 plus 1/5 is equal to 10, 5, 7, 7/10. All right, so let's add a page below. So what we have is 7/10 v initial square equal to 7/10 v final square plus gy final. All right, so what we're trying to solve for is v final. Okay, so V final 7/10 V final square is 7/10 V initial square minus GY final. Okay, and so V final square is V initial square minus 10/7 GY final. Okay. All right, there's the expression, and we'll let's put in the numbers. So V final is square root of V initial square plus minus 10/7 GY final, and this will be equal to initial velocity was 3 meters per second, so 3 square minus 10/7 9.8 meters per second square, and Y final was the ramp is 0.5 meters high. Okay, and this works out to okay. Okay, so 9 is clear. This works out to 1.41 meters per second. All right. So that's how fast the ball is rolling when it gets up there. Okay, in part B, what we want to find is will it get up on a, in part B, if the ramp is 1 meter high, does it make it to the top? Okay, so here's how we'll solve this. Let's find out what is the highest ramp it'll climb, and the highest ramp, the final velocity is 0. Okay, so we're going to substitute that. So 0 equal to Vi square minus 10/7 Gy final. Okay, so V initial square equal to 10/7 Gy. So this would be the highest ramp it'll climb. Okay, so Vy final is 7/10 V initial square divided by G. All right, and so let's see, what does this work out to? 3 squared divided by 9.8 meters per second square meters per second square. All right, so this will work out to okay, so this works out to 0.64 meters. So that's the highest it can climb. So of course it won't be able to get up on a 1 meter ramp. Okay. So that answers that question. So the answer is no. It will not climb up a 1 meter ramp. Okay, that finishes this problem.